Hi guys, today we are going to solve this lead code problem. Remove nth node from the end of the list. So it's a medium type. Given the head of a linked list, remove the nth node from the end of the list and return its head. So this is sample input. So we have the linked list like this, and here we have n equals to 2, and what we need to do? Delete the nth node from the end of the list. So if n is equals to 2, what it means that we need to delete the second element from the last, which is 4. So after deleting this element, our linked list will look like this. So this is our answer. Now let's see. If n equals to 1 and we have only one element, then we will get no element in the linked list. Alright. So let's see the constant. So constants are the number of nodes in the linked list will be from 1 to 30. Alright. It means our linked list will not be empty. Okay. Let's see how we can solve this problem. So basically we have this linked list. So nth element from the last will be equal to total length of the linked list minus n, and that element from the start will be the same. Okay, for example, let's say n equals to 2. Okay, n equals to 2, and so second element from the last, it is 4, and which will be equal to 5 minus 2, which is third element from the start. So when I'm saying third element, it means we are talking about 0 based indexing. So 0, 1, 2, 3. So this would be our node which we need to delete. So how we will do that? So let's talk about the basic approach, naive approach. So as we know that nth element from last will be equals to total length minus nth element from the start. So what we can do, we need to traverse the list in order to find the total length of the linked list. Then what we will do, we will subtract the value of n, and then we will get the element that we need to delete, node that we need to delete. Okay, so the pseudo code will be looks like something this. So let x be the position of the node to be deleted. Okay, so it will be length of the linked list minus n. Okay, so what we will do, we need to traverse the list from 1 to till this value. So our current in the initial position of the current variable will be this, and after this what we will do, we will move the current. So current will come here, then here, and then here. So at n barabar I equals to 3, the nth value will be come to here, and then what we will do, so after this loop will completed, the current value, what we will do, we will copy this value, this current next value to the current. So that's how I have done. Current value equals to current dot next dot value. It means that it will be 5. Okay, it will be 5, and the next node will also be 5. And then what we need to do, we need to set current dot next is equals to current dot next dot next. It means it will point to null. So end of the loop, our linked list will look like this. So this will be our answer. But again, here what are we doing? We are first traversing the linked list in order to get the length of the linked list, and then again we are traversing the list. So we are traversing twice. So do we have any better approach? So yes, we have, and let's see what's that approach. So for that, what we will do, let's say this is the n. Okay, n from the last, we will maintain two pointers, slow and fast, and in the starting itself the fast will be at n distance from the slow. Okay, so at the start only what we will do, we will separate fast and slow at the distance of n, and then what we will do, we will move this fast and slow simultaneously till this fast reaches to the end. So when this fast will be pointing to the last element, this slow will be pointing to the uh, nth last element of the linked list. So let's see how this works. So in the starting of the loop, the slow and fast will be like this, and then we'll move fast and slow simultaneously by one only. So slow will come here, fast will come here. So as we know that its distance will remain n because we are moving simultaneously with one increment only. Then after that what will happen, fast will come here and slow will come here. And what I said, when fast reaches to the last element, the slow will be pointing to the uh, element which is needs to be deleted. So then we will delete this easily. So let's solve this problem. So what I said, uh, I need to take list node. Okay, list node slow. So slow which will point to the head, list node fast which will point to the head only. And then I need to move fast n times so that the distance between the slow and fast will be n. So int I equals to 1, I less than or equals to n, and then I plus plus. What I need to do, I need to move fast by 1. Alright, now what I said, while fast reaches the last element of the linked list, we need to move slow and fast simultaneously by 1. And then when this loop will completed, our slow will be pointing to the nth last element, and then what I need to do, we need to point this slow dot next will be slow dot next dot next. Alright, and at the end we need to return the head of the list. So that is the case, but here as we can see that what if the length of the linked list will be equals to value of n. What I'm saying here is, for let's take the example of this scenario. Okay, we have 3 elements in the linked list. Okay, we have 3 elements in a linked list and the n value is also 3. Then what will happen, so nth last element will be this one. So we need to remove this, right? We need to remove this. So if we remove this, it means that we need to point this head to its next value, right? We need to point head here, then the link will form, right? Because if we not point this head to here, what will happen, if we are deleting this node, it means our head is pointing to null and it will leads to null pointer exception. So in that scenario what will happen, so see, if we move fast by 1, so in the first iteration fast will come here. Okay, so now I value is 1. So when I value is 1, our fast start moves and fast will come here. When I value is 2, the fast will come here. then when I value is 3, which is equals to the length, the first will point to the null, right? The first is point to the null. So we need to make sure we have covered that condition. So uh, if first equals null, it means that we need to move the head, because we are deleting the head element, right? Head equals to head dot next. That's it. And we are returning the head, right? Let's see. So it's accepted.